In question 11, the diagram shows part of the curve with the equation y equals to x power 1 upon 2 plus k square x power minus 1 upon 2, where k is a positive constant. In part A, we have to find the coordinates of the minimum point of the curve, giving our answer in terms of k. Now, to find the coordinates of the minimum point, we know that the dy dx will be equals to 0. So first finding the dy dx, so multiplying 1 upon 2 by 1, so that will be 1 upon 2 x to the power minus 1 upon 2. And this power minus 1 upon 2 will multiply by minus k squared. So that will become minus 1 upon 2 k squared, and decreasing the power of x by 1. So this is k squared, and this will become x to the power minus 3 upon 2. Now, as it is a minimum point, so dy dx will be equals to 0. We can write this as 0 equals to 1, and we can write the powers of x as positive. So we can write it as 1 upon 2 square root of x minus k squared upon 2x to the power 3 upon 2. Taking the negative on the left hand side, so that will become k squared upon 2 into x to the power 3 upon 2 is equals to 1 upon 2 root x. So cancelling the 2's, we'll get k squared is equals to x to the power 3 upon 2 divided by x to the power 1 upon 2. So 3 upon 2 minus 1 upon 2, so that will become 2 upon 2, so which is equals to 1. So k squared will be x. So the x coordinate is k squared. Now, once we have the x coordinate, we can find the y coordinate by substituting x equals to k squared into the equation of the curve. So as y was equals to x to the power half, so this will become k squared to the power 1 upon 2 plus k squared into, and this is x to the power minus 1 upon 2. So we can write it as in the denominator as x to the power 1 upon 2. And in place of x, we can write k squared to the power 1 upon 2. So y will be equals to 2 into square root, and square will cancel. So this will become k plus k squared, and again k squared square root will become k. This will cancel out. So k plus k will be equals to 2k. So the coordinates of the minimum point of the curve will be x coordinate will be k squared, and the y coordinate will be equals to 2k. In part B, it says that the tangent to the point at the point on the curve where x equals to 4k square intersects the y-axis at P. We have to find the y coordinate of P in terms of k. Now, in the first step, we'll try to find the equation of the tangent in terms of k. Now, the equation of the curve was y equals to, so that was x to the power 1 upon 2 plus k squared into x to the power minus 1 upon 2. Now, to find the equation of the tangent, we need the gradient. Now, from the previous part, we already had the expression for the dy dx, which was 1 upon 2, and we brought the square root x in the denominator. So that was 1 upon 2 square root of x minus k squared into, and k squared upon x 2 into x to the power 3 upon 2. Now, as the x value is 4k squared, so we can substitute 4k squared in place of x. So this will become 1 upon 2 square root of 4k squared minus k squared upon 2 into, again, value of x is 4k squared. So 4k squared to the power 3 upon 2. Simplifying this, we'll get, this will be 1 upon 2 into, and square root of 4k squared will be 2k. So that will become 4k minus k squared upon, so this will be 2 multiplied by 4 to the power 3 upon 2, that will be 8, and k squared into 3 upon 2, so that will be k cube. So square and cube will cancel out. We'll get 1 upon 4k minus 1 upon 16k. So as the denominator will be 16k, so this will simplify down. The gradient can be written as 16k, and this will multiply by 4, so that will be 4 minus 1. The expression for gradient in terms of k will be 3 upon 16k. Now we have the gradient, we have the x coordinate. We can now find the y coordinate as well to make the equation of the tangent. So substituting x equals to 4k squared in the equation of the curve, we'll get 4k squared to the power 1 upon 2 plus k squared, and we can write this in the denominator as square root of 4k squared. As minus 1 upon 2 will go to the denominator and become a positive 1 upon 2, and we know that 1 upon 2 means a square root. So the y coordinate will be K squared into 1 upon 2 will become K, and this will become 2K. So this will be 2K plus K squared upon 2K. So the square root of 4K squared will be 2K. This will cancel with K. So we'll have 2K plus K upon 2. So 2K plus K upon 2 will become, so taking the LCM, this will multiply by 2. So that will become 5K upon 2. Now, once we have the y coordinate as well, which is 5K upon 2, the gradient and the x value. So the equation will be y minus y1, that is 5K upon 2, equals to m, which is 3 upon 16K, into x minus the x value, which was 4K squared. Now, as we have to find the y coordinate of P, and it is y-axis, which means we can substitute x equals to 0. So at the y-axis, we can write that x will be equals to 0. So substituting x equals to 0, we'll get y minus 5K upon 2 is equals to, so x will be 0. So 3 upon 16K will multiply by 4K squared. That will become 12K squared upon 16K. We can cancel the k's up here, and we can simplify to write it as y equals to 12K upon 16 plus 5K upon 2. And once we take the LCM, so that we'll have to multiply this by 8 and this by 8 as well. So this will become, so 40K plus 12K will be 52K upon 16. And now we can divide it by, well, let's say if we divide by 4, so that will be 4. And this will become, so 4 times 13. So that will become 13K upon 4. Okay, but there's a small mistake, as the actual answer is 7K upon 4. So we'll just have to see where the mistake was. So the y value is 5K upon 2, the gradient is 3 upon 16K, and the x value is 4K squared. Okay, so we did not use a negative sign up here. So this was supposed to be a negative. So this will become y is equals to, so this is 3 upon 16K will multiply by minus 4K squared. So that will become minus 12K squared upon 16K. And this will be plus 5K upon 2. Now K and K will cancel. So we can simplify this to write it as minus 3K upon 4 plus 5K upon 2. Taking the LCM, this will become minus 3K plus 10K, which is 7K. And this will be upon 4. So the y coordinate, the correct answer is 7K upon 4. In part C, it says the shaded region is bounded by the curve, the x-axis, and the lines 9 upon 4K squared and x equals to 4K squared. We have to find the area of the shaded region in terms of K. Now, to find the area of the shaded region in terms of K, we'll first integrate this equation and substitute the values of x as 4K squared and 9 upon 4K squared. So the equation of the curve we know is y equals to x to the power 1 upon 2 plus k squared into x to the power minus 1 upon 2. Integrating both the sides to find the area. So area will be equals to increasing 1 upon 2 by 1. So that will become 3 upon 2. And we'll divide this by 3 upon 2. Increasing minus half by 1. So that will become 1 upon 2. And we'll divide by 1 upon 2. We can simplify it to write it as 2 upon 3 x to the power 3 upon 2 plus 2k squared x to the power 1 upon 2. Now, once we have integrated, now we can substitute the limits. The upper limit was, so the x value was 4K squared. So first substituting 4K squared, we'll get 2 upon 3 into 4K squared to the power 3 upon 2 plus 2K squared. And x is again 4K squared to the power 1 upon 2. And now we'll subtract it from the lower limit. So the lower limit was 9 upon 4K squared. So we'll write it as 2 upon 3 into 9 upon 4 to the 9 upon 4 k squared. So that is 9 upon 4 k squared to the power 3 upon 2 plus 2k squared into, and the y value is again 9 upon 4k squared to the power 1 upon 2. Now simplifying the expression, so this will become 2 upon 3, and this is, so 4 to the power 3 upon 2 is 8. K squared into 3 upon 2 will become k cube plus 4k squared square root will become 2k. So that will become 2k squared multiplied by 2k. And this will become, so 2 upon 3 into 9 to the power 3 upon 2. So that is square root 9 is 3. 3 cube is 27. K squared into 3 upon 2 is k cube. And 4 to the power 3 upon 2 will be 8. Plus this will become 2k squared into 9 upon 4 square root. So that will become 3 upon 2. And k squared square root will be k. So this will become 2 into 8, 16 k cube upon 3 plus 4k cube. And this will simplify down, so we can write it as 2, and this will be 4, this will be 3, this will be 9. So this will become 9 upon 4k cube. And this will be 2 and 2 will cancel. So this will be plus 3k cube. Simplifying this, we can take the LCM on both the sides. So this will become 16k cube plus 12k cube upon 3. And this will minus, and this will be taking the LCM up here. So this will also multiply by 3. So this will become 9k cube plus, or this will multiply by 4 as the LCM will be 4. So this will be 3 times 4, which is 12k cube. Now 16k cube plus 12k cube, that will become 28k cube upon 3 minus, and this will become 21k cube upon 4. The LCM will be, so the LCM in this case will be 12. 3 multiplied by 4, so this will multiply by 4, this will multiply by 3, this will multiply by 3. So 28 times 4, so if I multiply 4 by 28, the answer will be 112k cube. And 21 times 3 will be 63k cube. And now finally subtracting the two answers, so the final answer will be 49k cube upon 12 for the area of the shaded region in terms of K.